Hello, good morning everyone and welcome to the good morning everyone and welcome to the
Good morning.
5G security idea and prototype evaluation round. We have with us our jury members, Mr. Dr. Sanjay Bahl, Director General Cert-In, Dr. Somnath Chandra, Scientist and Director, Cybersecurity R&D, Ministry of Electronics and IT, Mr. Subhas Mondal, Head of R&D 5G Products, HFCL Limited, and member of IEEE Board of Governors, Mr. Vinayak Godse, VP-DSCI, Shri Narendra Nath, Joint Secretary, National Security Council, Secretariat, and also Shri Rajesh Jain and Shri Rajiv Gupta. Now, without further ado, may I please request the first presenter of the day, Mr. Abhijit Chowdhury, to the stage to give his presentation.
Yeah, good morning, everybody. I'm Abhijit, and I'm co-founder of Neural Networks. So let me try to share my screen. Is my screen visible?
Yes, Abhijit, we can see your screen. Please go ahead.
Yeah, thank you.
You have 12 minutes to present, and after that, there will be another 13 minutes of question and answer by the jury. Please go ahead.
Okay, sure. Thank you. At Neural Networks, we are building a private 5G network operating system. And I'm so sorry. Can you see my screen still? Actually, what happened is
we can see.
Yeah, no, my desktop. I lost the screen for some time. I was just wanting to understand. So, what we are trying to build a private 5G network operating system, and the reason that we are focusing on private 5G is that we are focusing on enterprises, digital transformation of enterprises, rural connectivity, and the privacy or like the security is a key important aspect for us. So today we will give a use case of unmanned banking, which we are working with IDRBT, which is part of the affiliated to Reserve Bank of India, and what kind of security use cases we are looking into. So I'll go through that. So if you look into the current setup in a rural sector, then what you see that India has around 6 lakh villages, and most of the banks, like branches of banks, like for public banks like State Bank of India or like ICICI, private banks like ICICI, especially the nationalized banks, is you have an office or a branch in the panchayat level, and within the panchayat, for say, you actually have 6 or 7 villages. But most of the time, and based on the research that we got, so the villages don't have a bank. So the idea was that when the villagers have to go to the bank, they have to actually go to the panchayat level. So which is it takes time, and also some things can be done in a better way. So the idea of the POC was to set up an unmanned banking for the villages as such, which are connected to the public, to the panchayat through a connectivity solution. So Neural works on providing a private 5G communication network. We do not work on the application layer. And we predominantly focus on the software, and which we'll describe a little bit later. So now the use case is to actually use the ATM as a kiosk and have a AR/VR solution through which, though you are not physically present in the bank, the villagers through the kiosk can have more functionality than ATM. I mean, they can directly talk to the bank personnel in the edge or in the branch, and the branch actually acts as an edge network for the 5G or for our private network, and it has most of the functionality to run the entire network. Even if the connectivity with the bank's data center is lost, because a lot of time the banks face this issue that the connectivity with the central data center goes down most of the time. But still, the connectivity between the panchayat and the villages would go on, and most of the function would be working. Some of the important banking transactions may get stopped for some time, but that once the connection is retrieved, they would be taken care of. So that was the idea, to set up a private 5G network, would help to reduce, ultimately avoid the capex of setting up new branches in the villages. And of course, because then you don't require less people, and so it reduces the maintenance and opex cost too, and saves time for the people, villagers, as well as for the IT personnel. Because if you have banks here, so you need personnel coming till the villages too. So overall, they see a huge benefit doing this. Based on the research done by IDRBT for Reserve Bank, and that's the use case we are working on, to actually provide a communication network in this site. I think all of you are aware of 5G. I'll not really go into that, but definitely 5G has an inbuilt architecture to provide low latency application like AR/VR, or like drone video surveillance, AGV, which requires very low latency and very high reliable network with the handover to work, and that's what we're looking at. And the other is the massive machine-type communication, which connects IoT devices and high throughput. But at this point, for this use case, we are more looking at low latency and high throughput within the private network. And of course, the security is also. Now, when you go to 5G, right, it has a lot of, it's great as a network from architecture and how it is designed, but it is also decentralized. Earlier, you used to have a LTE core, and you have the other radio, which would go to the backhaul to the core network. And so the single point of failure was the core. But now you have the edge network, which would be sitting maybe, as I was telling, in the Gram Panchayat, and they would talk to the core network. The edge network in itself is able to run on its own. If its connectivity to the core is not there, still it's able to. So you can see it's decentralized. The edge network can be a very single point of failure, right, of cyber attack and denial of service attack, through which you can, enter and then try to make an entry within the entire network. So if one small edge network is compromised, you can actually enter through that, and then you can actually spoil the actual 5G core network, not only that private network. So that is a problem. That's a challenge. And it can be resolved, and that's what is what we are working on too. And of course, the other part is the MITM, man in the middle kind of attack between the edge nodes and the cloud, right? And you can spoof what is happening, because the edge and the cloud, the vendors can also decide how exactly they want to define that. And if it is not secure, then there is an issue. And because of edge network and the decentralization, the number of configuration can be huge. So many nodes, right? So that has to be taken care of. And compromises on the edge node, because it's again not decentralized. So decentralized is a huge challenge, which has to be taken care of. And as part of this solution, we are taking care of that. So I'll come to that in detail. So again, the kind of attacks which can happen, the MITM, the DDoS attack within the edge, and of course in between the edge and the core connectivity, and physical compromise also can happen in the edge network. So we have to be aware of this risk, and take care of that. So coming back to how we are doing that, Neural is a network operating system, and we are an open and disaggregated network operating system. And we have a solution for the entire private 5G from a software perspective. The transport, which is IP MPLS network, the edge and the core, which actually are the 5G UPF, SMF, and the PCF, that functionality all together. So we are building the software for that. And Neural is an open solution. So we work with a lot of open source as well as open communities. We work with some of the important, for example, some of the open source important projects like Danos, Magma, which are actually contributed by AT&T, Facebook. So our solution has contribution from some of the biggest companies in the world, and we also contribute to that. The next part is the disaggregation. So our solution works on a COTS kind of hardware, any off-the-shelf hardware. So we have quite a few ODMs with whom we work, H4, UFSpace, Supermicro Acton, and we are also one of the global known network operating system in the TIP community. And apart from that, we add our curation, I mean, making it secure, scalable, robust, interoperable. So overall, these three together forms our OS, neural operating system, which we call curated, open, and disaggregated network operating system. Our IP is mainly on the curation and on the integration of the solution. So we have actually on the transport, we have solution which runs from 10 Gbps to 300 Gbps on different kind of hardware, like from ARM to Intel DPTK to Broadcom. On the edge part, we are working on the deep packet inspection and the UPF solution. And we have a lockless operating system which works with hand in hand with Linux to give on a bare metal to give a very high throughput. On a server, you can read 40 Gbps kind of throughput. And of course, the controller, you need to manage all of them. So that can run on a VM, and it can be outside the private network on a cloud too. And you can manage the entire like 5G software through that. So the management control, policy control. This is the kind of like a high level design of what we have in each of that. The transport part is this part, which is more of IP MPLS network. The edge part is more of this, which are the UPF, SMS, AMF, and DPI and some of the other components to make this. And you can run third-party MEC application within the private network. Like this is where it will be run. And all of this can be housed in a single box or multiple box within the private network. And on the controller side, to manage that, you have the SDN control, network management, and on the 5G core management or policy, you have the PCF, UDM, and other components. So that's how we are segregating. I mean, the edge and the core and the entire network component that we are building. So the private network would look something like that. And I mean, this use case is more for manufacturing, but the same thing holds for. So we have an edge gateway, which is something like this, which will hold the MEC applications and some of the 5G core application, and if required, some of the IP MPLS part also. And you will also have routers here. So the 5G GNBs is something which again we'll buy from vendors who already have such GNB. We are not focusing on the radio part as such. We are focusing more on the transport and the core part. Right? So from the GNB, we'll have a disaggregated cell site gateway or a router, and then it will connect to the bank branch, which will have the edge gateway, which would be like a COTS server. But for the routers here, it can be a white box from HCore or like from other company, and and the banking solution itself would with the I mean the ATM or kiosk I told. I mean those actually would be communicating with the 5G radio cells. So and for backhaul communication, there are two ways to do that. I mean this how they communicate. Either you use a fiber, but mostly you won't have fiber in rural connectivity. Like maybe in manufacturing it's feasible, but in rural you won't have a fiber. So what we do is that you can actually use a backhaul radio network for that. So I'll just go quickly now. I mean, because I think almost on the time. So we are recognized as a global and disaggregated open router operating system in the software with some of the big companies. Same in TIP, we are recognized. This is how our solution would look like. So if you see, with the edge gateway, we have a DPI, so which will ensure that DDoS attacks are mitigated, and the connectivity from the edge to the core network is over a secure VPN connectivity, which will ensure that there is no MITM kind of attack. It's encrypted. And same security would be maintained within the private network. The private itself tells that it has to be secured. So we would maintain the security required. And all the communication or management of that, the provisioning zero touch, as well as management would be controlled through the SDN controller, which would be, so the misconfiguration can also lead to issues. So that would be ensured from here. And as I was mentioning earlier, in the banking, for example, the SDN controller can be in the cloud data center, which is in the city, whereas that's not mandatory. I mean, in some private networks, you can have it near the edge too. I mean, within a private network, the controller can be in the edge or on the cloud.
Mr. Chaudhary, you have just 1 more minute left, so I'd request you to wind up.
Yeah, sure. So this is a high level audit of the POC that we are doing. So the edge, if you see, would be on the bank branch, which will have the neural edge, and the transport, as I told, may require some routers, white box. So that would be the transport network we have. And in our current setup, the core, I mean, the controller would be on the bank's data center on the headquarters. So that is the POC we are working on, and we are ensuring it is completely secured and running on top. I mean, the connectivity from the panchayat to the actually the data center would be over a public network, and it would be secured. So our differentiation started by myself and Inder. We have a very good background in like networking and telecommunication and multiple patents, and actually we have deployed the solution in India. Not this, but we have direct experience of developing and deploying solution in India, US, Southeast and Middle East Asia, which we have ourselves developed in our previous companies, supporting 4 million subscribers and put in the operators network already in like 4 countries. We are recognized in NASCOM, IDRBT, which I mentioned, TSDSI, and like your story too. We are one of the top startups for last year. Thank you, and happy to take any queries.
Thank you, Mr. Chaudhary. May I please request our jury to put any questions that are there from?
Yeah, so may I ask a question?
Yeah, sure.
Please, Mr. Mondal.
Yeah, thank you. Hey, Abhijit, thanks, great presentation. So I just wanted to understand from the 5G security standpoint, if you are having a private 5G network, and I assume that you are connecting a couple of branches in the village using your private 5G network.
Yes.
So one of the things that could happen is that you will have your banking application in a different trust zone compared to 3GPP trust zone. And there is a key hierarchy that is being used into the 5G node hierarchy to ensure the domain security. How are you leveraging the 5G security framework that exists within the 3GPP domain in the banking domain?
Okay, it's a very good question, and I mean we have had that discussion. I mean, at least to some level. I mean, in a different perspective. So the thing is that the banking application has to be very secured. I mean, from their perspective itself. So generally, in the I mean, unfortunately, in the current bank situation in the panchayat level, right? Ideally, they should have a DMZ zone. I mean, demilitarized zone where they will run such, where they will have a gateway. I mean, so the one that I was showing earlier, this is a simple way of looking into that. It doesn't have the banking application. I was showing it more from the communication part. And the edge compute that I was talking, some applications running here would be more of the AirVR and such applications which are not secure. For a secured the banking application, it within the edge, it has to be another server. It won't be not be the same one. It would be a separate server which would be sitting here. And if you see the banking application as such is not talking to the 5G directly. It is talking more with the through an IPsec or an SSL to the so it's not in the 5G purview because that is already existing, but the current existing solution is not good enough, which I have understood. So we are creating a separate server and a separate instance for that, which like whenever which will have a the IPsec gateway, it will and a DMZ zone, but within the resource they need. I mean, because it's a bank branch and a small branch, they won't be able to create too much different servers to and the right DMZ kind of demilitarized zone, which will have a IPsec gateway and then a router and then the application, and then you bring the 5G edge part. So it's a challenge of the cost, and that we have to see. Ideally, it should be IPsec or the gateway, and then you have the router with a net, CG net, so that I mean the IPs are also different, and then you have the banking application running, and from the router the other would go to the DPI or the 5G edge application. So there will be a router which will go to the edge, or and the other part would actually go through the banking application. It won't be directly connected. And
so Abhijit, sorry, that is fine. So help me understand. Instead of 5G, if there is a 4G network, or for that matter any network, what is the differentiation in your component that is coming from 5G perspective? That's not clear to me.
Okay, so we are bringing the DPI part, like before the edge gateway, right? As I was telling, it will run part of the core network, like the UPF and some part of it will not all the, I mean, which is required to run a public network would be here. And along with that, there will be I mean, before it enters or goes outside the edge gateway, right? We'll have a deep packet inspection, which will actually consume all the packets which are going through the network. It would inspect and ensure whether there is an attack. So it would actually do, I mean, one is signature matching, and also it will use some of the like heuristics to match whether there is a kind of an attack. And if there is a kind of attack, then it will have a policy which can be configured from here to either block that traffic, or it can actually redirect the traffic. So based on the policy applied. So you can apply policy from here, how to react when you see that there is some packet which looks to be like a denial of service attack, or that kind of stuff. The other thing is that the DPI will collect all flow level statistics, which will go back to the controller, and there you can.
Sorry, Abhijit. Sorry for interrupting, but how is that the security edge gateway or DPI you can do irrespective of the type of the network, right? It doesn't matter whether it is 5G or 4G. So I'm not still getting the point. What specifically for 5G is being done, I am not able to understand that. So if you can help focus on that part, it would be very helpful. Thank you.
Okay, for specificity, that you correctly mentioned the DPI can be irrespective of the 5G network. So, but why we are focusing on 5G per se is that we are trying to run this application, right? If you are trying to use some other network, you may not be able to do the use case for unmanned banking because of the latency and the throughput required within this public network. So that's the reason why we are using 5G. And I mean, we are also focusing on 5G because you can run the edge.
So are we saying the DPI that you have, right? So the DPI would be catering to the latency requirement. Is that an innovation here, or because DPI is what the question is? The DPI is you can always use the DPI for conventional network as well.
Exactly. Yeah. No, that is true. The DPI, what I was trying to say, within a private 5G, what extra security components we are bringing. So that was what we are looking at. DPI you can put in any kind of network. That's true. But we are using a low footprint DPI within the same box. Like in some cases, right, as I was mentioning, you may have to have within a single box the edge and run the DPI and everything. You cannot buy another component. We are trying to provide a single portable solution which runs them.
So that's the innovation. So you have that controller which has the DPI capability, which can withstand with the throughput, right?
Yeah, the DPI may not have much relation with the throughput, but definitely we have innovated that even on a small pitch server, it gets high throughput.
Okay.
And it can run.
Sorry, Abhijit, I'm interrupting. This is Rajiv. Just a couple of questions related to what Subhas and Vinayak have asked.
Okay.
So even with the LT cups architecture, DCN, which is akin to network slicing, you could have a similar kind of a deployment in LT. And the latencies which you are looking at 10 millisecond order, that is very much possible with LT as well. Right. So I think the question is, how is it specific to private 5G? Why not private 4G? Another question which I would have, I think, is in this disaggregated architecture, right? What happens if, because the subscriber security is of paramount importance. What happens if the connectivity loss happens between your centralized controller and this edge cloud, right? Then how would that banking service be affected? Because you would want the subscriber to be authenticated. And as Subhas was mentioning, there are two different trust zones which are here. One is the 3GPP and the other one is the application level. So can you just throw some light there? What is the thought process there in terms of your threat modeling?
Right. Yeah. For the first question, I think we have chosen 5G because we are all starting from scratch, right? Like we are a greenfield or a startup, so we are starting from. So we can work on LT, but because we are starting, so we have. I mean, for us, it makes much more sense to start focusing on the technology which would be for the future and which actually can cater to that. We can do with LT, but like at this point, all our our software that we are building is for the 5G. So it's more of what we are focusing. Having said that, our part of our component, like this routing component, right? Actually, we have gone to some RFQ with operators, which is independent of private 5G, and it is for LTE also. Similarly, the SDN controller. But this thing, the DPI also similarly can go with 4G. But this part may not directly go, right? So, but as this solution, the banking solution, is the use case itself is how to actually do those like the unmanned banking with private 5G. 5G, they came to us because we are building private 5G solution. And it's also one of the, I mean, you can do it LT, maybe you can do it some other network also. But the thing is that they are building a future network which is for future, right? And because it's a greenfield development, it makes sense for them to focus on more. I mean, from a 5G, I think more companies are building open hardware and white box for 5G because 4G is already deployed, or maybe deployment is still going on, but 5G would be of more paramount importance to have it more open hardware. Right? I cannot put, I may not get enough hardware like boxes which would work with a 4G solution, interoperate, I mean, with the solution. But 5G, the hardwares are also available. So it's more of a company strategy and also the alignment to the use case or the customers we are working with. I'm sure there are other technologies you can work with. The second part, so the second part was about so that is one thing. See, we are currently focusing on building the edge part actually. The core network and the SDN controller is almost built. And these are some of the challenges we are looking at how to take care of, because connectivity would go. And that is like we are putting some part of the UDM and some of the things which are required to create connectivity, ensure connectivity is there. We are putting it here in the edge to ensure that subscriber connectivity and security is still maintained. So that's how it is being done. So though it has so it will be replicated. Part of that would be replicated here. So we are still working on that design because this development is still going on. Like we have like more or less worked on the UPF. Now we are getting the SMF and the AMF UDM working on the edge. So hopefully that gives some sense to the second question that you asked.
Taking the question further from what Mr. Mondal suggested, actually there is, as far as I know, that there is a fundamental difference between the security implementation in 4G and 5G. And one of the key concepts is that you employ network slicing concept here. And to ensure security, you maintain security between the layers and as well as across the layers. So if you could clarify, because here also it is not very clear how you are employing different slices in a 5G scenario, and how you are maintaining security in each scenario, in each of the slices. If you could clarify, then I think your innovation part would be more focused.
Okay. So yes, so we would be actually working on the network slicing. We have not started working on that because at this point it's a private 5G, right? So network that we are trying to build. So, but I can share some insight of what we want to do. The network slicing again would be controlled from the SDN controller, and based on the use case, we would be from the controller out here, we would be configuring the network slice here, and for that use case, who are the subscriber or what are the security levels required would be configured here. At this point, it is not there because the private network itself, because we are not building, currently we are starting with a private network. So we have an idea of what applications we are running initially. And for that, what are the kind of...
And no, Mr. Chaudhary, my question is that yes, you are developing a 5G network for rural banking application. That is your core idea. But that network has to communicate with all the conventional network. For example, if a person is holding a network of an operator and he wants to communicate, so how are you ensuring security of his communication between the conventional network and your private network? If if you are developing any software component, then if you could clarify that part, that would be easy for us to understand.
Okay, so to give you some idea, and on top of what I was telling, like when you create a network slice, let's say for one for the banking and one, let's say for something like an IoT or a surveillance, like a video surveillance. Let's say there are two slices which are configured from here. And if you see, the SDN controller would be running a transport network, right? Because we have to ensure end-to-end the slice is managed within the private network, and which will have the IP network and also the core network, right? So what we are trying to do is that we are creating a VPN kind of MPL, like if you know a VPN solution within the MPLS, like we are creating a VPN label for MPLS separately for each slice, and based on what kind of bandwidth requirement you have. I mean, we have not developed that. The MPLS part is there, but the slicing we have not integrated. But I'm just sharing the insight of how we are trying to do that. We'll create a separate MPLS for this network, like let's say this network.
Abhijit, sorry for interjecting. Why would you go for a VPN when 5G LAN feature is available? Have you considered using 5G LAN feature?
The MPLS VPN that I was talking is Subhas, is more from a perspective of the IP network. So it actually uses, like, IP works on a MPLS levels, like, and you give quality of service, like you want high throughput, or based on that it uses a different kind of traversal of the packet, and for which you need low latency, you have a different packet traversal. For that, you will create a MPLS label, which will have a different topology of the transport network itself. So it's called a VPN, but it's not a VPN like a virtual private network. It's like a virtual label which is created to create a different.
So Abhijit, I understand. My question is that why cannot you use the 5G LAN feature?
5G LAN, we have, I would say that we have not explored that yet. Like for now.
Yeah, my request would be please take a look at it and then see if you can, your problem can natively be solved using the 5G LAN feature.
Okay, so if it covers IP MPLS or ITF network, it would be, I think, useful, and so I'll look into that, like the 5G LAN. Okay.
Thank you, Mr. Chaudhary, and thank you, jury. And in the interest of time, I would like to conclude Neural Networks presentation and invite our next presenter to the stage.
Sure. Thank you. Thanks for your time and have a good day. Take care. Bye.
May I please request Mr. Floyd DeCosta?
I am getting logged off every now and then, saying that there's someone using a new tab or something. I don't know. After every 2 or 3 minutes, I'm getting logged off.
Okay, sir.
Shri, can you check that? I'll ask Shri to check it with the player, sir.
Yeah. Okay.
So, Mr. Floyd DeCosta, if you could please turn on your camera and as well as your microphone.
Hello.
Hi, good morning. Good morning, Mr. DeCosta.
Hi, good morning.
Good morning. So I would please request you to share your screen and start your presentation. You will have 12 minutes to present and 13 minutes of jury Q&A.
Okay. I need to present a PDF or I can present a PPT too?
You can present either, sir. You just need to share your screen.
Share screen. No. Got it. Is my screen visible?
It is. It is. If you could please go in the presentation mode, that would be really great for us.
Moving right now. Looks good.
Yeah. Thank you. Thank you. Please go ahead, sir.
All right. Good morning, folks. My name is Floyd DeCosta, and I'm one of the co-founders of Block Armor. It's nice to see quite a few familiar faces here. We are a Mumbai and Singapore-based cybersecurity venture, and our entire aim is to look at how can you leverage modern approaches and emerging technologies to counter growing cybersecurity threats in bold new ways. When it comes, we've accelerated by Airbus and featured as one of the top 25 cybersecurity innovations worldwide by Accenture. And our claim to fame and the whole thing around the telco world, we were finalists at KPN, which is the Dutch telco's IoT 5G challenge last year. We were also finalists at the NTT Startup Challenge in 2020 and are now taking the solution to market in Japan with them as partners. Again, for a brief overview, and I'll keep this short, we were founded in 2017. My co-founder is a guy called Narayan Neelkantan, who's the former CISO of the National Stock Exchange, the NSE. My other he spent over 16 years there building many of the systems ground up. My second co-founder is a guy called Abhijit, who ran the SOC, or the Security Operations Center at the Stock Exchange. And I myself am a management consultant by background, spent over 11 years with Capgemini, led industrial manufacturing globally, and was part of the core team that built the digital practice. I'm also an alumni of IIM Bangalore. And between us, what we bring to the table is deep expertise in securing critical infra, but also the ability to grow international business practices. Like I mentioned, last year we were named among the top 25 cybersecurity innovations worldwide by Accenture. We've also featured among the top 20 cybersecurity startups globally, back to back in 17, 18, and 19. Earlier this year, we were also selected by IDRBD for part of the 5G challenge in delivering, again, the whole idea to deliver secure next-gen networks for banking and payment services. For a very, and this is where I think sometimes I'm preaching, it's like preaching to the choir. Today, smart connected devices have become an integral part of our lives, whether it's at business or at home or even within government, right? And with the advent of 5G, this is just going to scale multifold. Whether it's smarter homes or smart offices or connected cars and autonomous trucks or industrial control system and the whole blending of IT and OT systems. And of course, at a much larger level, smart cities, the IoT market is simply, expected to kind of grow exponentially and boom in the coming digital era that we are a part of. But one of the key challenges is when you're looking at the whole Internet of Things space and 5G networks that ties a lot of these things together, what you have is previously closed systems now opening up to remote access and control. And that's where the challenge lies. Existing security solutions are no longer able to keep pace, scale up, and address this all new security challenges we face in today's, always on, continuously connected 5G and IoT world. There are a number of, instances where systems have been compromised. The latest being where, in February, hackers gained access and attempted to poison the water system in a city of in Florida, and then more recently, where number of critical infrastructure systems have been compromised. Energy systems, utility grids being compromised are again examples worldwide today. You hear of some, you don't hear of many. And that's where, and like I mentioned, one of the biggest problems is we are still using yesterday's technology to secure critical infra against tomorrow's threats. And that's where you see today modern approaches like zero trust, which are swiftly becoming the preferred security paradigm for this connected world of ours. According to what the analysts are saying, if you look at what the analysts are saying, 80% of new digital business applications will be accessed by zero trust network ZTNA, and over 60% of enterprises are expected to phase out traditional private networks in favor of ZTNA. Now that's our story about how the shift is happening. I'll tie that shortly into 5G. Like I mentioned, Block Armor, we were accelerated by Airbus, and what we've developed is a integrated end-to-end zero trust cybersecurity solution. One single platform to secure critical enterprise system, critical IoT systems, connected devices, and the associated networks. 5G networks is what we are currently piloting with multiple telcos in at least 3 different jurisdictions worldwide. And this is the main slide that I want to focus on that talks about the architecture. I'll come to the underlying in a moment, but this is where our goal is to see how can we deliver ultra-secure enterprise or government networks over 5G. We're not building the 5G networks. What we have or what we deliver is the integrated zero trust security overlay. Now that not necessarily just run across the 5G networks. What we are talking is about end-to-end. So what our solution is, and I'll come to the slides which talk about what we're using to power this, is what we call the Block Armor Secure Shield Controller. That's our award-winning technology that we built, and we built it. The innovation years we built it on blockchain technology. We use private permission blockchain technology, and what we have is next generation digital identity and access management for all users and connected devices. Please pardon me, I'm at home and that's the battery, but I'll skip that. So what we are talking about is on the right-hand side, you see the number of users and connected devices all over the place today, and that is our new hybrid and distributed enterprise world today. But also on the left-hand side, you have users that are still sitting in offices.
Mr. Floyd, I'm sorry for interrupting you, but at least in my screen, I cannot see your presentation.
Oh,
can you refer
so?
to the slide number? Can you refer to the slide number so I can look offline which slide?
Number 7, the architecture. But thank you, Subhas. I just want to check with the others. Are you all able to see my screen?
It is visible to us.
Thank you, Vikas. Subhas, that's the architecture slide, yeah?
Okay.
So Yeah, so what we are talking, not just the 5G network, because it goes beyond. So you got the end-to-end, which is the smart city, the connected devices on your right-hand side, but also down to your cloud and your or your data center where your critical infrastructure is happening, and the whole thing connected via 5G networks. Now, I'll come back to this slide in a moment. 3 use cases we are working with telcos today is number one is which is this whole new normal post-COVID-19. And how do you enable secure and compliant 5G-based remote access for employees, contractors, and teams working remotely? The other one, which is something we are taking to multiple jurisdictions, is how do you create that ultra-secure 5G backup networks for critical infrastructure organizations like financial institutions, utilities, railways, ports, airport, and other critical infrastructure. Should the terrestrial networks get compromised, how can you have a secure 5G backup network, right? But here's the thing: we've at least had 2 cases with one government agency saying, perhaps going ahead, that might not be the backup network. That could be the primary network, with the terrestrial network becoming the backup network in the future. Last but not the least is how do you create this integrated end-to-end secure smart city, smart factory, or industry 4.0 network using 5G. These are 3 case studies we are working with right now and exploring and even piloting the ability to deliver this using 5G networks that are being trialed in multiple places worldwide. Just to share, go a little under the hood, the solution is powered by 2 key technologies. One is software-defined perimeter architecture, developed and used by the US military and the Department of Homeland Security. This is where we take the critical infrastructure and make it invisible. How do you attack a system you can't see? How do you DDoS a system that you don't even know exists? And on the other side, what we have is private permission blockchain technology, and that's what we use to create digital identity. The secret sauce is we use digital signatures, not just the IP addresses, which most solutions use today, to identify, authenticate, and authorize devices, which makes it very well suited for today's distributed hybrid enterprise IT environment, but also smart city, industry 4.0, and 5G related security use cases. Today we work with partners, and that's our real go-to-market approach. Like I mentioned, we when it comes to telcos, we partner with NTT, and this is a lot of work we're doing about going to market in Japan. We were selected last year by the Tokyo Metropolitan Government for its support program to bring block armor to Tokyo, and now working with the #1 telco there to deliver on a couple of the use cases that we pitched. Number 2, like I mentioned, we were finalists at KPN's challenge, and we had a call last week with them to kind of revisit the whole digital identity and security. A lot of it around IoT and 5G systems that they're looking to roll out. Last but not the least, of course, in Singapore, we are testing it with the largest telco out here, again, delivering end-to-end security over 5G networks. Apart from working closely with the folks at DSCI, we are also we're also working with IDRBT to see how we can look at next generation, secure next generation financial networks, both payment, banking networks, and delivering the same level of security that's currently available over terrestrial networks, also via 5G systems. Here's the team, and those are my partners in crime there. They are the cybersecurity guys. Narayan, and that's 19 years already, securing India's financial markets, former CISO and head of IT and risk and compliance at the NSE, and Abhijit, who basically ran the Security Operations Center, worked under Narayan for over 11 years at the NSE and now has over 14 years of work there. Together, we've also built up a core team, most of it sitting in Mumbai and in India. We've got folks in, Satya on the call is in Bangalore, we've got folks in Delhi. And yep, we put together a team to take this venture, to scale it and truly deliver next-gen cybersecurity. That's my last slide there. And I think I'm good on time. And happy to, but let me go back to the main slide so I can park it there. So if we have any questions, happy to pick it up from there. How am I on the timing?
You're just about. Yeah.
Perfect. Then I'll leave it at that.
Thank you. Thank you, Mr. De Costa, for the presentation. May I please request the jury to ask there questions to Mr. DeCosta?
May I?
Please go ahead.
So, Mr. DeCosta, you talked about software-defined perimeter.
Yes.
So I just wanted to understand what specific security aspect of 5G network that you are going to use in your solution.
Okay, so what we deliver is the end-to-end security, right? So number one is all the components within the network, right? So whether your servers or whether your edge systems, by deploying our agent on that, we are able to make it invisible to unauthorized users. Number one. Okay. So this cannot be accessed, cannot be even seen by folks that are not authenticated. Number one. Number two, so like I said, there are two key pieces. One is our main controller. Number two, we have a little agent that is deployed on every device. Now, if the device is too small, let's say sensors and things like that, then we have a gateway.
I'm just participating.
And everything that behind the gateway is secured. So coming back to your questions, it's not just the network, and again, it's the end-to-end system, which is right from your servers down to your remote user devices and the connectivity in the middle. Just since you asked that question, we use 4096-bit encryption to secure any data that's tunneled through our network.
So, not sure if I got what I was looking for. So, let me elaborate a little more. So, in a 5G network, you will have a 3GPP trust zone and non-3GPP trust zone. And if you see the difference in the security architecture, there is additional components that are added into the 5G network security architecture. So my question more was that, let us say that you have a 5G core network giving the data connectivity at N6 interface, which is getting into internet, and now you have let's say the application servers hosted right at the N6 interface or beyond the firewall that is shielding the 5G core network to an application server in the public cloud.
Correct.
So my question is that, considering that you have the applications hosted either within the let's say the trust zone of 3GPP or outside the trust zone, how exactly are you interfacing, integrating, and leveraging the 5G security features that it offers? That was my specific question.
Very good point. And when we started out and we were talking with a couple of the telcos that we work with, here's the thing, right? And this is natively offered by the telco as a service that comes with the 5G network. The point where we got invited was that today a lot of enterprises, especially the critical infra ones, the organizations, would look at end-to-end security. So if you look at this from the end device beyond the 5G network onto the public or private cloud or the data center. And the thing is twofold. When you go beyond the 5G network, how do you deliver the security end-to-end? So that's where they invited us in. The second point is also that many of the organizations, the critical infra ones, actually came back to say that, yes, we have, the security, the 5G security, which is a huge enhancement over what 4G had to offer. But would we trust our application or this critical applications in the hands of the telco, right? And that's where we got invited in to say, can we deliver that extra overlay, that extra security overlay that you have the 5G security that's already being delivered, but now you have the organization security that runs on top of that and becomes that additional layer, that additional layer or that tunnel that's there, that's ultra secured, right? So we don't directly leverage the 5G network security, we run on top of that. And so that's why, should the line shift to either terrestrial or 4G or any other network, the same level of security is available to the organization.
So whether it is 5G or 4G or any other network, how would it really matter? So how is it relevant for 5G alone then?
So here's the thing. For number one is, are we able to deliver this over 5G? And that's what we started to pilot. Number one. Number two is the technology at the controller level to identify and authenticate and the agent sitting on the edge, on the end, your edge devices or your user devices, which are automatically able to maintain that security should the network also switch.
Okay, thank you. I'm done.
Yeah,
I think
one
taking
question.
off from what Mr. Mondal said, have you found any challenges when you talked in terms of are you able to deliver over 5G? I mean, are there specific unique challenges that you found compared to if you were deploying that over a terrestrial network or a 4G network?
Correct. Now, again, it's the there are two things here. Number one is that the 5G network also has the edge, and a lot of compute is starting to move into the edge because of use cases that are there. And there are two things we are testing. One is the ability to deliver it over the 5G network. The second thing is also to secure the edge, the servers that are sitting at the edge, and take it one level further to the end user. Can we deliver the end-to-end? We look at the remote user here, you have an edge device here, and it goes over the network and to the other end. So right now, we don't have a challenge, but to be very honest with you, we're still testing this.
So you can actually run this over a terrestrial line or a 3G network. Is there anything stopping you from running it over those?
No, we've already delivered it over 4G.
And what sort of threat modeling have you carried out? How do you ensure that your blockchain itself cannot be compromised?
So we use the blockchain, and that's a very good question. So we use the blockchain for three things, right? One is its decentralization. Number one is today, if instead of the blockchain, you'd have databases and things like that. You compromise them, you take out the database and you can compromise the system. With the blockchain, if you want to compromise the blockchain, you've got to take out at least 51% of all the nodes. Number one, you need to know how many nodes are there to calculate 51%. Number two, you need to be able, oh, Mr. Subhas left. Okay. Number two, you need to be able to know exactly where those nodes are placed to be able to compromise them. So even if you get one node to yourself, it will all be gibberish because it's natively encrypted within the blockchain. And that's what makes our solution unique. Not to mention the decentralized nature of the solution allows us for fault tolerance and failover instantly from one node into the other should it ever be required. So even if one node goes down, no problem because all the nodes are replicated across the blockchain network. Just a point to stress here, it's a private permission blockchain network that we use, not one of the public chains.
Okay, and you said you already deployed this over 4G. Where exactly have you deployed this over 4G?
So this was one of the, Sanjay, sorry, I'm on the NDA, but I'll say as much as I can say. This was when we were accelerated by Airbus. We did some work on aircraft security. And that's where we actually incubated the IoT and the ability to go over a 4G network during a pilot with Airbus.
Was there any performance degradation?
None. Our agents have very little footprint, and so if you're talking about, so that's the thing, right? And we come from the team comes from a background of from the stock exchange, right, where it's microseconds and things like that. So yes, there is a very minute lag, but no, not enough not enough unless or to be able to also be able to serve low latency networks.
So you said agents, you have a small footprint of agents. So these agents have to be sitting on each of the edge devices?
Yes, or alternatively, we put a gateway in front of these devices so that anything sitting behind the gateway cannot be accessed by unauthorized users coming over the network.
Just one question, sir. You're using a lot of different terminologies. We have laptops, phones, and sensors connected to internet.
Correct.
So what is the influence of your technology? What is that goes into this final devices used by people or machines? What do you push through?
We have a small agent of ours that sits on all these devices. So if it's a laptop, it's something like your VPN, but of course it's using zero trust, right? So it's not a simple direct VPN tunnel. So it's a little agent that's deployed on your device. And this is once deployed, it registers itself against the blockchain. The user has a username and ID, which the device is also registered on the blockchain. The user logs in and validates himself. The device then validates itself against the blockchain, and the combination of the user and device ID then opens a secure tunnel to the servers. The agent sits at the kernel level. So that is right one level above the network, and so we are able to manage and monitor everything coming over the network.
So you have to be very careful which final devices you use this, because the user is going to pay for it. For example, low bitrate services cannot afford some things like that. On the other hand, you have to say exactly where this is applicable: smartphones, tablets, or meters.
Smartphone, tablets, laptops, and yes, any other devices where the agent can be flashed on.
So this is, yeah. So I presume this is not really applicable to sensors, because they can't afford this kind of extra software.
We are yet to get there, but one thing is, number one, any device that has an IP can be used. Number two, but yes, it can, unless the sensors depends. Today, if you look at cameras and things like that, yes, we can deploy it on that, but the sensors, no. When it comes to sensors, we put a gateway in front of these sensors. So a single gateway, and then everything sits behind that.
So what you said, what's the footprint of this client that you're putting in? So it is the sensor would not be able to accept that footprint.
So depends what kind of a sensor, because today you do have sensors with some little compute and and a little storage, right? Which this can be flashed, need to be flashed by the OEM ideally, but or the service provider. But the minor sensors and things like that, pressure sensor thing, no, it wouldn't go on those.
So when you're talking in terms of onboarding network elements, you would only do the aggregator, not the individual IoT devices.
The traffic, sorry, could you repeat that?
What I mean is, when you're authentication, onboarding of an IoT device is an important part of the whole
Absolutely.
process. Correct. So the onboarding of IoT devices is not part of your solution.
No, every device has to be registered on the network to be able to access or to be able to connect to the main server. So if it's your laptop or your phone, yes, it would have to be registered. And so it would need to be onboarded.
Yeah. So in other words, if there is a rogue device, problem we are solving, right? If a bunch of rogue devices come and disrupt the network, there's nothing you can do about it.
No, they won't be able to access the network.
What is that?
They won't be able to access the network. If they are not registered on our network, they won't be able to access anything.
No, I'm talking about the radio access network. They can go and kill the radio access network.
Oh, no, that's out. Yeah, that is.
Where the network, there are two. I mean, that's what is the 5G network.
Correct.
Then on top of it, you have some other application level security running, I believe.
Yes, our system runs on top of the existing network.
But without the client going into the IoT device, how are you going to have a registration process which is secure?
Ideally, we would have our agents sitting on the client, but like I mentioned, if there are certain very like you mentioned sensors, no, that would sit behind the gateway, and our gateway acts as the validation point into the core systems, to the data center or your critical service.
No, that's not entirely obvious. If I'm running, what is this gateway really? I mean, as far as the user device is concerned, it doesn't necessarily see any gateway, right? It sees the end, let's say it's a water meter or gas meter application. It sees the end application directly. How are you going to introduce this gateway in between?
So it has to go over an IP network, right? And so we put this in front of the where it connects into the main network, the meter or whatever the device is. By the way, on a meter, we should be able to. In fact, we have a use case where we were talking to one of our partners to be able to deploy this on certain meters. Our agent is customizable and we would customize it for these meters, and the agent would sit on the meter.
What kind of physical demonstrations have you carried? like real prototype demonstrations of what sort of areas?
So number one is the solution is in use for general cybersecurity use cases. We already have paying clients, and we already deliver the solution worldwide. Coming to your on the second point, we've actually done a couple of smart city pilots that we're working on. Number one, securing camera and camera feeds into the core servers. Number two, we're looking at a certain set of devices that we would run over 5G. Right now, we are looking at laptops and smartphones going over 5G. And this is one of the things we're doing with our partner in Singapore. Number three, we now look in talks with multiple OEMs who we can partner with so as to be able to flash the device and offer this next generation security, partnering with the OEM and participating in things like smart city projects, IoT projects, and things like that.
So what is your model for supporting this? Is it going to be directly through you, or is it through partners? What is the plan?
So we are the guys that provide the base platform, right? Our go-to-market is purely partner-driven. So number one, we work with the OEMs that form the first layer of partnership. Number two, we also work with system integrators that are able to deliver the solution to organization.
But that's from your sales and implementation perspective.
Ownership, no. Our entire solution, we give it to the company, to the organization. So we deliver it as like an on-prem kind of a solution.
But the organizations would require support, maintenance, upgrades. How is that happening?
Either we provide it or we have partners that deliver this.
Okay.
Our go-to-market is purely via partners. I hope I answered that. Kiran, just to answer your earlier question, we currently also testing the solution at the National Cybersecurity Lab in Singapore. And this is where we've got servers, and then we've got agents, and then we are looking to work with a couple of institutions to test real-world cases, right? Ideally, I'd like to do something with medical devices, but then also other critical infra like airport ports and things like that.
Thank you. Yeah. If there aren't any more questions, I would request Mr.
I have one question, Vikas, if time is there.
So please go ahead, sir.
Okay, thank you. Yeah, Mr. DeCosta, one question regarding the 5G or 4G network, whatever is inside, which is being used by the block armor, the secure shield, right? You mentioned that you have worked on these, and few microsecond is also possible. But in those scenarios, maybe the 4G or the 3G network may not give that kind of latency, all right? So would there be some dependency on the underlying network which your application wants, your agent wants, and the user has to subscribe with that with this network which is being used for this communication?
No, whichever network the enterprise or the organization is using, we run on top of that. We are quite agnostic there.
So but you mentioned that you need some kind of quality of service parameter, right? You mentioned that it can work within a few microseconds also. Then you need some support from the underlying network, right? There should be some criteria which you want the user to fulfill before they can use this application.
So here, number one is we would need some a place to deploy the controller that could either sit on-prem or in the cloud. On the other side, we would need to be able to deploy the agents, and that's it. That's all we need to do. The other network that runs in the middle would be whatever the organization is using. And whether it's within the perimeter or outside of the perimeter, that's where we stress on being able to deliver zero trust, right? Truly zero trust across a hybrid or distributed network.
Okay. Thanks.
Yeah, one last question, Mr. DeCosta. You mentioned about onboarding. I think there was an earlier question. If I understood correctly, the onboarding would be at a manufacturing level, right? You cannot onboard once it is out of the factory.
So the flashing of the agent would happen if, let's say, it's not a laptop where it can be pushed by the administration. The agent would need to be flashed by the OEM. Point number one. But the onboarding, which is every device gets onboarded onto our controller, would happen at the organizational level.
But yeah, the registration with your blockchain would have to happen at the manufacturing time, right?
No, at the deployment time.
Okay, so it would be some kind of a certificate based, which has been flashed into the device.
Yes, we use distributed PKI. Yes, and that would the moment the device is started and the agent would try to reach the controller and download the credentials and things.
Okay, and how does this blockchain technology scale, for bigger, larger organizations and the use cases?
So that's the thing. Number one, it's a private permission blockchain. Point number two, it is completely scalable because if you need additional users or you need additional access points, you can simply add nodes, and all the nodes are always in sync and always replicated, carrying identical information. Any one node gets compromised, it's automatically thrown out of the blockchain by the rest of the nodes that are completely in sync. And hence,
more the number of nodes in the blockchain and more the number of subscribers, the number of nodes.
Yes.
And if the traffic load is high, the more time it would take for the consensus to be reached by this blockchain technology, right? That is the way it would be into.
But again, you don't need all the nodes to be in sync. You just need a certain number of nodes, and then it automatically starts replicating.
Okay. Thank you.
But that's the whole idea of the blockchain. Apart from the security, the decentralized security being delivered, you also have the ability to deliver a robust and scalable system when we use this private permission blockchain.
Yeah.
Okay. Thank you. Thank you so much, Mr. DeCosta. And with that, may I please request you to exit the stage?
Thank you.
I would like to invite.
Such a pleasure to be able to present to you. Thank you.
Thank you. Thank you. I would like to invite our next presenter, Mr. Sanjay Betragunta, to please start his presentation.
Yeah. Okay.
Hi, Mr. Betragunta. You'll be able to share your screen, sir?
Yes, I'm doing that. You see my screen. So can you see my screen?
Yeah, your screen is visible now. Yes.
Can you see my presentation? Am I audible? My voice is clear?
You're audible. We can see your presentation. You may please go into presenters mode and we can start. Perfect.
So, respected jury, good morning, namaste. So I'm Somnath from BITS Pilani campus. I'm a faculty here. I've been working at BITS for the past 6 years after completing my PhD in IISc Bangalore. So thanks MeitY, thanks DSCI for giving me this opportunity to present my idea. So let me make this clear. So this is related to physical layer security, right? I'm not going to talk about the very big picture, the giant 5G or next generation 5G and beyond architecture, etc. I'm not going to talk about those things, but my focus is on simple, physical layer security protocol design and development. Okay. So here is the outline. So it's like basically I'll develop the ground for the foundation for the physical layer security, its importance. Then I specifically consider a lattice model. So some problem statements and then some new problems and then the testbed proposal, like probably how it can be developed, implemented, some results, some very preliminary results which we got recently. Okay, so this cartoon, this illustration talks about the millimeter wave cellular network where we have so many nodes and the interfaces, right? So we have the base station, we have so we have the user equipment and so on, right? Eavesdropper and so on. So when you talk about 5G, right, there are various technologies coming to picture, like specifically, for example, here I showed millimeter wave. The fifth generation new radio specifies two frequency bands, FR1 and FR2. So frequency range 1, frequency range 2. Okay, so the focus could be here like a sub 6 gigahertz band, which can be used to develop the test bed. So the problem with millimeter wave is specifically the directional beamforming, right? So there's analog beamforming, digital beamforming, hybrid beamforming, which can improve the secrecy capacity. But the problem is the eavesdropper influences secrecy capacity. It will degrade the performance of secrecy capacity. The physical air secrecy capacity I'm talking about, which depends on the SNR, received SNR. So the key idea is, can we exploit the intrinsic random nature of the feeding channel to ensure physical security? So the 5G techniques to improve secrecy capacity and efficiency, like spectral efficiency, energy efficiency. Okay, so there are MIMO techniques, there are millimeter wave communication technologies, like cooperative communication, full duplex, non-orthogonal multiple access, and recently proposed RSMA, rate splitting multiple access. So the focus here is considering the cooperative communication techniques to improve physical air secrecy capacity, where we use a hybrid relay, right? So hybrid relay that can process optimally in order to optimize secrecy capacity while meeting the energy efficiency criteria. Because when we talk about the 17 sustainable development goals, the climate action goal number 13 is important. So while developing the protocols, right, we have to keep in mind about the energy efficiency performance of the protocols also in the mind, because that's very important given the current climate action, the SDG, Sustainable Development Goals proposed by United Nations. Okay, so coming to the physical air security versus cryptography, right? So like, in any network for that matter, 5G or 6G, so there are these things like reliability matters. So for example, the error probability, we talk about in physical layer, simple error probability. So we talk about frame error probability. So these are reliability measures. And then similarly, we have security measures. We have spectral efficiency, we have energy efficiency. So these are all important performance measures that are to be carefully analyzed and optimized for any network for that matter, not just specific to 5G. So the physical layer security, as I mentioned before, exploits intrinsic characteristics of wireless fading channels. For example, fading interference to improve the signal reception, the SNR at the receiver. For example, one can employ maximal mining to improve the SNR and SNR, because all the physical air performance measures essentially are functions of received SNR. SNR stands for signal power to noise power ratio. So it degrades, but problem is presence of eavesdropper degrades the performance. So secure transmission without secret keys possible, physical layer security. So because given that IoT, there are millions of IoT sensors, low power sensors. So using cryptography, it's burden for it. So we use reliability at different layers, across layers. We use various error control mechanisms, techniques. Like we have different forms of coding across, right? We have starting from the basic line coding, we have channel coding, secure coding, right? So we have space-time block coding, so many things, right? So particularly, it's good to focus on physical layer security to reduce the burden of this cryptography. However, depending on the applicability, depending on requirement, we can use security at different layers, as mentioned by one of the previous speakers, across the layers and between the layers. So physical layer security is a promising solution to secure industrial IoT, cellular IoT, right, 5G and beyond. The advantages, for example, does not depend on encryption, decryption operations independent of these encryption, decryption, and can fully exploit the characteristics of fading channels, adaptive signal design. We can realize there is resource allocation, and then it requires less overhead compared to cryptography approach. So now the focus will be on cooperative relays to improve physical secrecy performance. Now this is the simple proposed lattice. However, we can even have a diamond lattice architecture also, where there is a destination, there are eavesdroppers, there is a relay in between. And then we assume that we assume half duplex, of course, can be extended to full duplex. And when the source is transmitting, we assume that these nodes are not eavesdroppers, only these two, even E2 are eavesdroppers because they are far away. So so the model and assumptions and novelty here are like we assume half duplex, frequency flat, fading channels, for example, like Nakagami fading channels and time division duplex system. MPSK MCOM transmitter, and the tertiary nodes, note that the tertiary nodes are not eavesdroppers. So we can further just simplify and have a diamond lattice, and then we can develop a simpler test bed just to proof of the concept. I mean, not just concept, the protocols, the optimal policies. So the novelty lies in the design of designing hybrid decode and forward or generative relay to optimize end-to-end physical layer secrecy capacity. So this is the main novelty. So there are papers in literature that talks about using cooperative techniques to optimize, enhance end-to-end physical secrecy capacity. And however, the novel idea here is using hybrid decode and forward relay. So hybrid in the sense, depending on the channel conditions, this adaptive relay will set an optimal gain function that will maximize, that will optimize the secrecy capacity and energy efficiency. Right? So we can also do the joint optimization as well. So the problem is to determine secrecy capacity, fading average secrecy capacity, both in cooperative and non-cooperative lattice structure. To compare secrecy capacity in both the scenarios, right? We can compare with the optimal scheme with the suboptimal schemes, and we can evaluate the probability of intercept and as well as the other performance measures. So this is some illustrative plot with the, right? It's a preliminary plot that just compares the non-cooperative and cooperative scenarios. Cooperative IoT lattice model delivers better performance. You can see instantaneous secrecy capacity. But in general, we plot average secrecy capacity. So the objective is to, some of the objectives are designing optimal power adaptive and variable gain DAF relay that optimizes physical air secrecy capacity and studying its performance gains in terms of secrecy capacity and energy efficiency. Okay, so with the presence of perfect imperfect CSI. So in theory, what happens is like we consider assumptions, idealistic kind of assumptions like perfect CSI. CSI stands for, by the way, CSI stands for chance information. But in practice, there are various problems such as synchronization, channel estimation. So all these problems should be addressed while developing a working prototype test bed of this sort for physical air security test bed, which includes the cooperative communication techniques. It's novel cooperative communication techniques. So the prototyping, experimental validation testing. So these things are the objectives, like generally, and the test bed can be developed using the hardware software integrated platform, the hardware from USRPs, and then the IoT sensors and the GNU radio. Okay, so in literature, people, researchers implemented such test bed for cooperative system, for example. But as far as my knowledge is concerned, there's no test bed that designed specifically for optimizing this physical air security aspects. Then the protocols. So there's a requirement for developing this optimal protocol policies or protocols to enhance physical air security, secrecy capacity. Okay, so and cooperative techniques are really promising in addressing that goal, addressing that challenge. So obviously, there are various implementation challenges which include synchronization, parameter estimation for synchronization, channel estimation, hybrid beamforming, coded 5G waveform design, so on and so forth. So this is some recent model my students worked on. So they considered this model and then they developed a protocol and studied the impact of imperfect chance information on secrecy capacity in the presence of outage constraint. So the trade-off between CSI accuracy and spectral efficiency we studied here. Here you can see there's a source, there's a destination, there is dropper, there are multiple relays. Then there are various novel extensions are possible, like relay selection, then optimization of the relay processing to optimize the end-to-end physical layer secrecy capacity and so on. So these are some of the graphs we obtained. This figure shows SNR versus secrecy capacity. As you can see, as the error variance, CSI error, John state information, error variance increases, secrecy capacity decreases. So there's another plot where we showed that MRC improves, outperforms benchmark scheme, and higher the John state information, error variance, lower the secrecy capacity. And there are, so physical layer is fundamental, right? So any network you take, physical layer is very, very fundamental, right? So phi is very important. So obviously, so it's applicable to various very big class of use cases you can think of, right? You can apply it in vehicular communication, you can apply in IoT, industrial IoT, or you can apply in terrestrial communication, satellite communication, whatnot. So these fundamental optimization protocols can be applied in any types of communication systems, I mean, and networks, cooperative, particularly like where cooperative communication is really an important candidate for improving the performance. And then we can extend further to cooperative and spectrum sharing systems, cooperative and cognitive systems as well. We can consider, for example, interference constraint into account, and then we can maximize, optimize the end-to-end physical layer secrecy capacity. So with this, I'll stop my presentation and I can take questions. So thank you very much.
Thank you, Dr. Sainath. May I please request the jury to ask their questions? You can stop sharing your screen, sir, Dr. Sainath.
Yeah, sure.
Professor Sainath, I'm Somnath Chandra from MeitY. I have a few questions. First of all, you have considered wave as your key system in the design. But as you are aware that there are other modes like FSO and optical wireless, which are equally promising, and these techniques like non-orthogonal multiple access and cooperative communications are also employed in optical wireless system, which offer better transmission capacity and spectral efficiency. So why are you particularly focusing on millimeter wave? And this is one question. Second question is that what are the signal processing techniques that you are using to enhance the secrecy capacity in the system? If you could kindly clarify.
Hello, Mr. Sainath. You might have stopped the microphone.
No.
May you please just raise your hand and I'll give you the microphone.
Yeah, I raised the hand. Am I audible now?
Yeah, yeah.
Yeah, you're audible now, sir.
Oh, good. So to address the first question, so on a bigger scale, like
But I am not able to hear Sainath now.
We can hear Mr. Sainath. Mr. Mondal, are you able to hear us?
I can hear you, but not Sainath.
I'm able to hear him.
Okay.
Yeah, I am able to hear.
Okay, shall I go ahead then?
Yeah, you can, but I am not able to hear Sainath even now.
Okay.
That was Sainath just speaking, so I think you're able to hear him now, Mr. Mondal.
Who? No, Sainath, can you speak?
Yes, sir. Yeah, yes.
Now I can hear you. I can hear.
Okay, sir. So to address the first question, we can definitely have a hybrid physical layer. In fact, I have some papers where I proposed hybrid physical layer and switching policy from FSO, millimeter wave, and RF, depending on the channel conditions. Recently, we got some communication letter as well for drone communication, basically. So it's indeed possible to extend it for a hybrid physical layer where switching can be taking place based on secrecy capacity instead of. So there we proposed the switching in terms of similar probability. So one such policy can be proposed for improving physical layer secrecy. So definitely, yeah. So in a bigger picture, we can have a hybrid architecture where we have FSO. So now, for example, the communication can start with FSO mode, and then depending on channel conditions, if there is no proper line of sight, it can switches to millimeter wave, and then it can switches to RF. So vice versa. So it's possible. That is one thing. And millimeter wave specifically is why I considered, because 5G NR, it's one of the important candidates. It's a lot of research going on in CVTX also, considering millimeter wave communication. And then given the problems of millimeter wave, like very high attenuation at high frequencies, in order to compensate that, we need to use beamforming techniques. So the signal processing technique, to address the second question,
Professor Sainath, one question is that the millimeter wave range is also limited. If you go on considering, then you have to employ many more hops in your network. So if you could specify what is the range of your system. For example, if you...
yes, the range is few tens of meters. The thing is, it can be developed for indoor channels, outdoor channels, and combination of indoor and outdoor. So there are three possibilities at least I could think of. For example, the test bed can be located inside indoor environment, as well as it can be completely lie outside the, outdoor environment, and then it can be part of both. For example, there could be some part of the nodes can be inside, some from the outside. So that way we can analyze the performance in various channel environments. And as you said rightly, so the millimeter wave has few tens of meters range, very short range. However, with the help of cooperative nodes, relay nodes, we can extend the range. And that is one thing. Another thing is with beamforming, we can improve the performance. So the compensation for attenuation will be done using efficient beamforming, directional beamforming techniques.
Yeah, that is okay. One idea is to go for the beamforming. But why you are not considering several advanced modulation techniques, which also give you some kind of enhanced spectral efficiencies?
Exactly. Yes. So yes, though I mentioned MPSK-MCAM transmitter, definitely there are recently one of the popular modulation techniques that are proposed is OTFS, orthogonal time frequency space modulation. It's better. It delivers. It has been proved that delivers superior performance compared to OFDM. However, there are under, for example, mobility, particularly there is Doppler spread. It has been proved that OFS is better, but its complexity is high compared to OFDM. So there is a trade-off between complexity and performance.
My submission is that while submitting the proposal, if you could actually clarify your deliverable portions, particularly say if you go for say 1.5 year or 2 year deliverable, say in the first year what you will deliver, second year what you will deliver, and ultimately what test bed you offer. Would it be a software, would it be a hardware software combination? So that thing requires a little bit more clarification.
Yes, sir. So the deliverables are very clear. So first, the thing is the optimal policies, spectral secrecy capacity optimizing policies, and associated software that will go into the test bed, and then obviously a working test bed. These are the test. These are the actually the deliverables. So you see the technology readiness level, as industry people very well know, the TRLs, technology readiness levels. So in academia, the fundamental research starts with TRL 0 and 1, 2, etc. So first the policies will be, the models will be designed and they're evaluated and then redesigned till we get the best performance, optimum performance, and then we develop, we put them in the test bed, in the nodes, we put the software in the hardware, and then we eventually we test it, validate it, and then finally we deploy it for the users to use it, right? So TRL 0 to TRL 9.
So up to which TRL level you propose to go? Say maybe TRL 4 or 5 in this case?
Yeah. Yes. In this case, it's 4 or 5, correct? Because it's, there are various limitations in academia research. Not only just matter of financial support, but also various other limitations also. So given that at least so whatever working prototype, so that's good enough for industry to take it further, because in industry there's a lot of workforce, a lot of intellectuals, working professionals. You can take it further to apply it to these protocols to various other scenarios, not just in terrestrial communication. I'm talking about, for example, you have the backscatter communication, the narrowband IoT. So there are other communication systems like drone-assisted communication systems. So these are generic in nature, which can be applicable to various bunch of networks, right? You can see because the fundamental is a physical layer, right?
Okay. Thank you, sir.
So, just for my for clarification, how exactly is that signal degraded to a non-legitimate user?
Yes, sir. So
Professor
what happens is,
Sainath,
sir?
Hello?
yeah, sorry. May I ask a question?
Sir, I'll finish this question and then,
Yeah,
sir,
yeah.
so the presence of eavesdropper, what will happen is the mathematical expression, if you see, you have log 1 plus SNR of the intended user minus log 1 plus SNR of the eavesdropper. So the eavesdropper will degrade the performance in that sense, like, because so his contribution will come into picture. So it's like kind of destructive nature of the eavesdropper, so which will further degrade the secrecy capacity, the physical layer secrecy capacity.
So you have to first recognize who's that non-legitimate user, isn't it? Before you apply. Yeah, yeah.
Correct.
So how do you do that
Correct.
recognition?
Yeah, so that has to be done. So there will be initial procedure, the kind of analogous to the handshaking procedure we have. So there can be kind of the procedure where detection of eavesdropper takes place. So the preamble should be used.
Okay.
So it's all about you use some packets to estimate, to detect, and then eventually we do the communication, right? So that sort of thing. So that pre-processing should take place before actual communication takes place.
Okay. So that process of detecting a non-legitimate user is not part of your solution. Once you have a information about non-legitimate user, then the degradation part is part of your solution.
Yes, exactly. Yes, because when we really start implementing it on a test bed, then eventually there will be lots of problems will pop up. So definitely we have to address those problems step by step carefully. And the protocol should be revisited, reiterated till we get the desired optimal solution.
Okay.
Yeah.
Okay, thank you. Mr. Mondal,
Yes,
go
sir.
ahead.
Can I ask a couple of questions in case Mr. Mondal is not?
Sure, sir. Please, sir. Yeah, sure.
Yeah. So,
No,
Professor
I am
Sainath.
able to.
I'll
Please go ahead, sir.
Vinayak.
Mr. Mondal. Please go ahead. Then I'll ask after that.
Yeah, but I think, see, what is happening is I'm able to hear some people, not able to hear others. So I was not aware that some question discussion was going on. Sorry about it. So, Mr. Sainath, sorry, I didn't hear everything that you said. So I'm asking a very fundamental question. So, what is the centrality of your proposal? Are you suggesting a new ciphering scheme, or just utilizing the diversity and using the that diversity and intrinsic channel characteristic to propose a new scheme for security?
Yes, sir. So here the novel idea is to come up with an adaptive relay which can optimize the performance. So the relay has to kind of the relay has to the policy. So the optimal secrecy capacity policy sets the optimal gain function of the adaptive relay so that it will optimize the end-to-end average fading average secrecy capacity, physical layer secrecy capacity. So this is the main idea, sir.
So, what is the definition of secrecy capacity?
So the secrecy capacity is so there are two things. When you talk about random channel, like there's instantaneous secrecy capacity, which is a function of SNR of the intended user. So it's a logarithmic function of intended user minus logarithmic function of unintended the eavesdropper. So since the instantaneous SNR is a random function, it's a function of random variables which account for these fading distributions. So we have to take expectation, the average. Fading average with respect to channel fading. So that is the secrecy capacity definition. Yeah. So when there are no eavesdroppers, then there will be further more degradation in the secrecy capacity.
So,
Yeah.
Sainath, I probably will have multiple fundamental questions. Maybe if you can point me to some literature or some publication that you have submitted, if you can share that with me. I am trying to understand that how do you know who is intended and not intended, right? Because the security association may not have happened yet, right? So how do you really distinguish a rogue versus the intended user?
Yes, sir. So that has to be. I mean, as I mentioned, there will be detection mechanism should be figured out, identified to identify the unintended user, eavesdropper, and then eventually applying this optimal policies to maximize the energy efficiency, spectral efficiency.
Okay, thank you.
1 second. Just
may I go ahead and ask a couple of questions, Professor Sainath?
yes, sir.
Yeah,
Yes, sir.
Professor Sainath, the 3GPP is also defining the relay node technology, which is more of L2 relays rather than the physical or the layer 1 relays. So do you think this prototyping which you are doing could gel with that also? That is one question. Or how it can be adapted to work with the 3GPP defined relay nodes. The second question is, if I understand correctly, using the hybrid delay and forward nodes, means in future, whenever it has to be commercialized, right, the operators would need to deploy these relay nodes. Can this technology work without the relay nodes with the normal GNBs which are deployed, let us say in sub-6 or other spectrums where the coverage is much better?
Okay, so to address the first question, so regarding the 3GPP standards, so I didn't particularly mention about the relay type, whether it is addressing the 3GPP or meeting the standards of 3GPP, but it can be kind of devised to meet the requirements of 3GPP standard relay specifications. And another thing is when we deploy with redundancy, so redundancy and reliability is another two R&R. So these two are very important. When we can deploy more nodes, relay nodes, then definitely with kind of best subset relay selection, we can address the problem of coverage. So if even few nodes will fail, the others can still have the ability to take the communication forward. So that kind of redundancy and reliability can be improved. So definitely given, so the idea of 5G, if you see, so the millimeter wave, when you think of millimeter wave short range, so we need ultra dense network, right? So you need an ultra dense network. So definitely we need to kind of increase the infrastructure. But then comes to the green, addressing the SDG, Sustainable Development Goals, we need to think of using alternate energy harvesting mechanisms, kind of, for example, renewable energy to power up some of the nodes, right? Instead of using traditional, conventional energies that contribute for CO2 emissions. So that's what I can right now address, right? I mean, answer.
Okay, thank you. Thank you.
Thank you. Yeah.
Professor Sainath, one more question. You have presented slide number 6, I believe, where you mentioned this physical layer secrecy versus the cryptography part.
Yes,
so you mean to say that the cryptography will be replaced with this, or would both go in hand in hand?
It depends, sir. It depends, because when you think of IoTs, low power IoTs, so there is no free lunch, right? We have to consume energy for each task. Okay, whether it is simple task or bigger task. So depending on the application, the requirements, whether we can go for physical layer security alone, or we can go for security at different layers, across layers, or between layers. So it's not just I say cryptography we have to omit. I'm not saying that. So I'm saying I'm giving a humble comparison between these two. So if cryptography is required for specific applications, so in addition to that, we can use physical layer security to enhance secrecy capacity. So that's the idea.
Okay. And in case the crypto or the 5G security procedures are also enabled, how the eavesdropper you will be able to recognize, or means how those signals can be decoded to read what is being exchanged for that user, because the higher layer application is already encrypted all the packets which are being exchanged, right? How exactly means then it would work?
Yes, sir. There should be a protocol. We have to redefine the protocol in such a way that the physical layer optimization should also include able to decipher the required keys and then do the further process. For example, you see, we have secure encoding, secure decoding should be there actually. So that physical layer should have the ability. Yeah.
Okay, so you mean that there should be something which the standard needs to redefine for
yes,
this?
Yes. Exactly. Yes.
Yeah, that makes sense. Otherwise, I was thinking like if cryptography or the existing 5G procedures, because they don't allow, other than the emergency call, they don't allow all the calls without any security.
Yes. So in addition to security, in addition to secrecy capacity, the focus is like energy efficiency is another important focus we should really think about, given the contribution of information communication, automation technology. I see 80 contribution in CO2 emissions. It will be hitting up to 10% at least contribution. So given this condition, so we have to, whatever we design, we have to redesign system to keeping energy efficiency in mind, at the same time improving reliability, secrecy, capacity, etc., and so on, other performance.
Yeah, effectively, I was thinking in those terms only before the slide which you presented, that it is more of reliability towards means how to utilize those physical layer procedures and how to optimize the performance there.
Yes, sir.
Thank
you. Thank you, sir. Thank you, sir. Thank you very much. I really had a nice time with you. Nice session. Thank you.
Thank you. Thank you, Dr. Sainath, for joining us today. Now, I may please request Mr. Faizan Wani to raise the hand so that I can give him the microphone rights.
Yeah. So with your kind permission, I will leave, sir. I had to go to hospital actually.
Thank you, Mr. Sainath. You may please. Thank you. Hi, Mr. Wani.
Okay.
If I'm audible, you may please share your
Am
screen.
I audible, sir? Can you please confirm?
Yeah, we can hear you.
Okay, thank you, sir. Is my screen visible to all of you?
We can see your screen. You can put your presentation up.
Okay, so thank you.
There is also a bar saying that stop sharing. You may please hide it.
Okay, fine.
Thank you. Thank you.
Thank you. So, respected jury and experts, I warmly thank all of you to give me this beautiful chance to firstly present my idea and interact with everyone. So, about me, I am a student basically, but I have been in network pen testing from the last 3 to 4 years. So, I got this beautiful opportunity to present my idea. So, once again, I thank everyone. Before I can really start my idea, I belong to Kashmir and J&K. It's always been a problematic area in context to security over the internet. So we have multiple reports here from the cybercrime department, from the J&K police, that people essentially what they do is they don't utilize the internet and every stuff present on internet in a good way. So we have a lot of miscommunication, we have a lot of misuse happening in J&K, and with the onset of VoIP, people are using free VoIP technologies. They just most probably terrorists here try to communicate via this technology, and in multiple reports our police and cybersecurity personnel have tried to tell that it so there might we face this trouble in detecting how and where the malicious packets came from, and a statement, how we can efficiently increase our cyber surveillance. And with the onset of 5G, I believe in a personal way that if there was, although we will have eventually in the future, but since not every person is a good person, and in fact in my part of region, so we believe that there should be a monitoring system on how people in those security areas communicate and how they really use that network. So for that, I have just made a very concise PPT and a little bit, I want to speak out everything. I just want to keep my idea to the point and just provide all the facts. So about my abstract, what I'm really planning to do is just have a login gateway first, wherein we can just know about the user, and just a login gateway like we have seen in airports, we have seen in wherever we try to connect to a public Wi-Fi. So that login gateway, what it will do, it will be a diverse login gateway, and this project will be applicable on a network level. So I'm not trying to go on a kernel level or stuff like that, or dealing with OEM, because we have had reports here that people try to mess up with OEM as well when we go into real, real on-ground situation. So there is a possibility with that as well. So I thought that we can keep this at the socket level, and best would be to deal with things at network level to keep all things in our control, being a security person. So what I really believe is, we can have a login gateway at this person. We can have a login gateway, and whenever a user tries, uses his mobile phone, he types in www.google.com. At the first, we have to make sure that there was a report actually. There have been personals in Jammu and Kashmir that tried to. Previous year, there was. I believe there were experts from Cisco and many companies that tried to do stuff like this. So I don't know what were the reasons they couldn't do this at the end of the day. But what I'm planning is we'll have a login gateway that will feed the results, and that will essentially let our user just download a network certificate. So that network certificate will be the heart of my project, and that will be dealing with everything that does. So I'll be using eventually Paint with this to demonstrate my project real quick. So once we have all the stuff from the user, and that login gateway will only read the HTTP headers. So what really will grab from the HTTP headers, because we have HTTPS right now, we can't really analyze the traffic, the real stuff, what they're trying to communicate, what they're trying to do. But we can have the HTTP headers, that whether the user is going to google.com, he's going to evil.com, he's going wherever he is going, and that is what we can eventually fetch from our ISP as well. But with the onset of this project, we'll have two benefits. Firstly is, we'll have things in hand. Our security personals will be having things at quick hands. Secondly, we'll be able to analyze the traffic as well, even if there is an HTTPS secure connection. And how we'll be doing that essentially is, firstly, I just want to throw a quick, by having logs in our hand, we'll be able to craft a pattern of our adversary. Suppose that we have, I don't know whether you have heard, we have security regions like Pulwama is there, or certain areas of our, Kashmir, to be very precise. There are, worrisome areas. So we can deploy this stuff there. And after that, when we come to know that people are using VoIP, we can know which website they're connecting to. Then what when we have the logs for that case, we know that there is text now an application that provides VoIP service. So we know that it's using https.com, and we just have the logs by right now. After that, first let's have a glance at SSL or the HTTPS for that case. Although there are other secure mechanisms as well. There is FTPS, there is SMTPS. There are many protocols that are secured, but I'll take example for HTTPS right now, because mostly we are facing trouble with that stuff in our area. So I am a user here in my left side, and we have a server right here. So our browser knows that we are connecting to https evil.com, since this has a certificate here that claims, hey, I am https evil.com, and that goes back to the user, and the user at his end, this browser validates it from a trusted certificate authority. That's the main game. So it really it confirms that this certificate was just issued. But there are two main kind of handshakes that are happening here. Firstly, this server here is sending the certificate that claims, hey, I am this https evil.com, I am really the one. And at the end part, when this receives the feedback from the server, it tries to validate the certificate, and if it failed in validation, it will allow the connection, but it will display a little triangular sign or on the top left, showing a yellow color kind of warning, but not red. It will show a yellow color, hey, this is a trusted connection. So that's the main fact behind that HTTPS protocol. So how essentially this project will work. So we'll have a algorithm in between, we'll have a jump server in between kind of. So I just want sir, can I use Paint real quick to demonstrate this stuff? Hello.
Sure, Mr. Vani, you may go ahead. Just be mindful of the time. You have 6 more
Okay.
minutes left.
Okay, sorry, sir. I'll just do it quickly. So we have, a user here who will try to communicate to a big server, and the connection will go. The user will drop a request to this server, and the server will try to validate via the certificate back. So what we'll be having is we'll be having a jump server in between. So jump server used to be a problem initially when we had, we had to deal with the amount of requests that would go through that jump server and all that stuff. But with the onset of blockchain, with the onset of, cloud technologies, I don't think that we'll be having to deal with a lot of traffic for that case. And with the onset of P2S technologies, with the onset of, Bastion hosts, we can develop all these stuff real quick. And we'll in between this we'll have a small server, so a jump server for that case. So what it will do is it will tell this guy that, hey, I am https evil.com, and to this https evil.com it will tell, hey, I am this guy. So eventually it will be capturing this request as well and this response as well, and then it will be acting like, hey, when it will be sending back the response to this guy, so it will be self-signing. It will be acting like a self-signing authority, self-certificate signing authority, and this is actually a cybersecurity attack. So this is SSL stripping for that case. But this will be manually signing the certificates, and to this it will be acting like this server on the right side, and to this it will be acting like a normal user. So that's what I have pretty much conveyed in magic time. But there is a small hypothesis that I'm currently working, and I'm not pretty sure how we will be able to control that part. That is the yellow part of the point that I said. Firstly, considering the fact that our certificate won't be verified from a trusted certificate authority. So I have had brainstorming sessions on this, how we'll be able to do this, how we'll be able to push the user to believe that this is the certificate. Maybe when we just issue the first certificate, first network certificate, when a user logs in to our connection, he'll get the first network certificate. We can bind something to that will enable us, or that will make the user blindly trust the certificate. Even if it doesn't trust the certificate, he can eventually allow the communication, because the connection won't be terminated. It won't be designated as a red flag. It will be just as a yellow flag. So yeah, that's pretty much about my project, and thank you.
Thank you, Mr. Vani. May I please request our jury to ask questions, Mr. Vani?
Am I audible, sir?
Yeah, you're audible. Hello. Jury, are there any questions for Mr. Vani?
Yeah, I think we need to go to the next presentation. The president will separately talk to you, because some of these ideas are not really coming in the realm of discussion that we have it here now. So we will separately, as a DSA team, will talk to you.
Okay, sir. Thank you, sir. Thank you so much.
Thank you, Mr. Vani. And may I please request our next presenter, Mr. Murugavel from Cosgrid, to raise his hand so that I can share the mic with him. Yeah.
Hello. Yes, can I go ahead?
Yeah, Mr. Murugavel, you may please share your screen and start your presentation.
Yeah. Sharing the screen. Okay, present audience. I should click the present to audience.
Yeah.
Good morning, good afternoon, distinguished jury. This is Murugavel Muthu, founder and CEO of Cosgrid Networks.
Murugavel, we can't see your screen yet.
Okay. I have shared it.
Present to audience.
Okay, I haven't clicked the share. Sorry.
Yeah.
You're able to see now?
Yeah, it's coming. Just give it another minute. Yeah, it's there now. You can. Perfect.
Yeah.
You can hide the little tab in the middle.
Is it okay now?
It's okay. You can just hide the tab in the middle that says stop sharing.
Okay. Okay. I understand. Thank you. Yeah.
Okay.
Okay. Yeah. Yeah. Hi. Good afternoon, everyone. Distinguished jury. This is Murugavel Muthu, founder and CEO of Cosgrid Networks. We are an SD-WAN and security product company. Today, we are going to look at the threat landscape broadly and security solutions from that we are proposing. A quick introduction about Cosgrid. We are a startup founded in 2016. The team has got a rich experience in building and launching global products in networking and security, more than 2 decades. Have a very mixed experience in working on technology companies as well as telcos as well. We have been granted Indian patent on SD1 innovation. Myself, I have personally worked on a GSMA i3 forums IPX exchange, which deals with the migration and interconnect, setting up global interconnects between various telcos, especially on voice interconnects, GRX, SS7 diameter signaling, and so on, which was, I think, I worked on almost 4 years back, 4 or 5 years back. So we are also winner of second stage in cybersecurity grand challenge that deals with the anomaly detection, IoT security, and SDN, and which is conducted by DSCI and MeitY. So I want to broadly talk about, because which is well known to the jury here. This some of the very wide lot of attack vectors that is happening. Broadly and specific to 5G, massive IoT use cases can be exploited by hackers. Small cells and edge can be another vulnerable area, and also cloud and edge security. I mean, because entire 5G is about cloudification. The rogue cloud service providers can also be a weakest link in the chain. And also, we're talking about multiple use cases where which is hosted in the edge, and this could be targeted by sophisticated hackers. So there are a lot more attack vectors are there. So the objective, the need of the hour is to have a solution that can detect zero-day threats with a better understanding of user behavior, context, IoT, and so on. So again, this is a quick representation wherever the attack can happen. It could be on the radio access network and whatever to the front hall, mid hall, and so on, right? And also the edge infrastructure, and as well as the edge infrastructure, and also on the apps hosted in the edge and cloud. And also generally virtualized core infrastructure, right? I mean, entire thing. And of course, CPEs and enterprises or homes that are connected. That is also one use case. So broadly, I'm touching upon what kind of threat can happen. This is a limited, in the list is very limited, highly limited. So RAN, I think we can have a tapping, there can be network taps and man-in-the-middle attacks and can happen at the RAN. In edge, DDoS attack, again, MITM, and a lot more. Of course, virtualized core infrastructure problem is completely a different problem altogether. That we are not going to deal with now in this presentation. And apps, of course, app security. There are a lot of interesting use case that is going to happen in 5G, whether it be smart mobility and so on. So, and ultra low latency and so on. So these applications can be, mission critical applications can be a target of attacks. And of course, CP and customer and enterprise networks also can, who are using 5G, 5G slicing, they also can be a target. Yes, now we have broadly, a lot of solutions and toolkits available in terms of firewall, UTM, next generation firewall, with a zero trust, TPM, crypto, microsegmentation, and so on, with a mesh. Okay, but then, the traditional approach may not scale with the 5G because network security is very complex. Especially 5G is much more, huge in terms of deployment, and the number of devices and so on. So we need to have a better approach, and that approach needs to be not a one size fits all. It has to be adaptive, context based, based on the user, based on the location, and so on, and the type of device and so on. It should be converging and integrated, because the approach can't be a piecemeal approach. It has to be integrated approach, and with much more intelligence, programmable. We must be able to react in a much faster way. It should be scalable and real time. So again, as a product point of view, what can be the requirements? It should have a low false positive and a false negative, much more automated, better recommendation through correlation, low operating cost, and should be able to handle DDoS reflection amplification attacks, MITM, APT, DNS tunneling, beacon, C2C detection, SQL injection, data exfiltration, and so on. So what our approach, what we are talking about, our cost grid advocates, is that instead of having most of the vendor today have one singular approach, or maybe two approach or three approach, right? But in today's world, where even yesterday we heard about there is the entire meat factory came to a halt because of some cyber attack. So we need to have a multi-pronged approach with a lot more complexity, but at the same time should be adaptive, right? So we are proposing multiple tools, multiple technologies, or multiple approaches, like statistical analysis, ML, protocol-based analysis, integration with global intelligence, and traffic profiling, anomaly detection. Also, traditional specification dynamic-based policy, as well as SDN, so one intelligence, as well as the micro segmentation with all the encryption and all that stuff. So 5G core, this is one classic use case where multiple NFVs are running on 5G. They have to be, network functions has to be themselves, whether it be signaling, data plane, they themselves have to be protected, and we can have a container based or VM network functions, which is VM based, UTM, next generation firewall, on multiple, the entire data center, cloud data center. It can enforce the policy in terms of micro segmentation, application level policy, and also intelligence based on the application, right? Specifically, it can have much more diligence on the protocol specific to 5G, as well as general encryption, VPN, and access control, and some level of limited visibility. So I'm just talking about various possible products ideas, or as well as product ideas that we can deploy. And again, there are some set of another set of product which is aimed at edge computing, attacking edge computing vulnerabilities. I think which is very, very is going to be a very diverse, and also it is highly distributed. Edge is going to be highly distributed, and it is going to be very challenging to manage them as well. So we need to have, because Edge is going to have hosting a lot of application, web application filter, malware protection, API protection, all those things can be hosted there actually. And again, 5G distributed code vulnerability. This is another challenging, very, very challenging. But at the same time, where sophisticated attackers can wreak havoc on the entire infrastructure, which needs a lot more intelligence, which needs much more, lot more visibility, correlation, analysis, and so on, right? So where we can have a lot of probes, network taps, and collecting multiple levels of inputs, and they can be used for anomaly detection. All those, whatever the security which I talked about, right? We can use multiple integrated approach to detect and mitigate it. Another interesting area, in fact, that needs much more analysis as well. There's going to be a lot more interworking roaming going forward. How can we protect the individual network from outside attack, from state actors from outside, the country or whatever, right? So there is already SEPP is there, so we can protect SEPP has got some level of security available, we can fortify much more, or we can implement our own way of SCPP, which can do a lot of both border functions as well as security functions. So in this overall picture, what we are proposing is that a security pulse orchestrator and defender, which is based on HC group NFA security, and also can deliver for general 5G security, and specifically for IoT smart city at a scalable model, we can propose. We are planning to use Anastica framework for IoT, which leverages NFA and SDN. So what the SPOD can do, it can do microsegmentation, RAN, radio access network security, DNS security, PKI based automated encrypted tunnels, mesh, basically based on mesh, and from a from a administration and assurance point of view, people who are logging, who are managing the networks should have, should be secured with the SDP, software defined perimeter, granular user access control, security compliance monitoring, and in compliance with NIST standards, and ATP. I mean, I think which I've talked about a lot of threat protection, which can use DPI and so on. Okay, this is another specific use case, based for IoT security, which can leverage Anastica framework, which I talked about it. This can be more like a overlay on top of the existing 5G underlay, right? Where you have a industry 4.0 where the devices are outside, smart city, where they are not within the premises, not within a perimeter, right? So how can we protect and defend these IoT devices, which is going to today it is very less, it's going to have a big sprawl, right? How can we have approach to protect, defend, and secure them? This is one approach which can be offered as a IoT as a service to the service providers, bundled with the service providers, and can be offered to the enterprise and institutions. So yeah, I think this is which I talked about, right? I mean, we need really a solid, robust, unified threat management. But this can be not necessarily like a hardware-based appliance. It can be network functions. It can be container network functions, right? Which is much more flexible, because the network, 5G network, is all about highly distributed in nature, right? So and it's not, and also it should be, the whole idea is it should be much more flexible and cost effective. It should not take off much of electricity or whatever, right? So CNF kind of model, at the same time leveraging some latest technology in forwarding plane, like P4 programming, and a lot of other DPDK and so on. So where we can work on 10G 100G level kind of thing, depending on the location where it is going to be there. Because I'm sorry, I didn't ask anything. I'm with you.
Yeah, Murugavel, we can hear you, but you just have another minute left.
So yeah, so this is a next generation firewall with the UTM. It has got a intrusion detection, prevention, authentication, the microsegmentation, and so on. So I will show you some demo as well, a little bit on that. So again, this is more of a, I mean, one is orchestrator, which I have shown. One is the policy enforcer. Another is a highly more like a SIM kind of thing, where which can have a comprehensive visibility into the network. So that is what I want to talk about, right? Which can leverage the latest technology. We're talking about ML. People are talking about federated learning and so on. So a lot more interesting stuff can be done. So that's a quick overview of the presentation. How many minutes I have left actually?
There's some time left for the jury question and answer. May I please request
so,
the
yeah,
jury?
I think that's all. I think this is at a conceptual level, so I don't want to talk about more on that. So I will just show some demo on that, whatever we have already done. Actually, I think that will be kind of meaningful. So we already have worked on device classification, IoT device classification using ML, and we have got a very good accuracy on that, more than 99.95%. 99.5%. Of course, there is a lot of scope to improvement. I think this will give us the context. This same technology needs to understand the context and accordingly do the policy enablement for individual IoT device or group of class of IoT devices. So again, we have done some, and as a part of our IoT security, we have done product development on this actually. So where we can do statistical analysis in terms of standard deviation, variance, and moving average, and so on the individual packets, connections, bytes, and so on. And also about beacons, detection of beacons. Beacons can be a positive, like Microsoft or Google have their own beacons to monitor their own devices. And also of course CNCs, which were what the malicious servers like MeitY or whatever, Tori, and so on. So we were able to do some both analytics and ML and see what are all the detected beacons and CNC connections actually, right? And also DNS tunneling, long connections, and and also what are the subdomain which has got more DNS query, because DNS is being used as a highly is one of the what to say, backdoor for a lot of attackers actually. So we need to do a lot more intelligence on analytics and intelligence on DNS queries and so on. So we also have that one. So this is just to talk about various data sets we have used, like UNSW data set to train and detect and validate the attacks actually. Whether we are able to and we are able to get 99.93. Of course, we have to improve more on that actually. So
Murugavel, may I please request that we move on to the jury Q&A? Hello?
Yeah, I have some more thing. 1 minute, I will just quickly run through. Okay, so there are some lot more things we have done. So anomaly flow identified, and unsupervised also we are working on. Actually, we have done something. This is about more of the visibility, which we have already have developed actually based on IP reputation, flow analytics, geographical based IP, autonomous system named flow analytics, and so on. And of course, DPA based flow alerts and analytics based on duration, bit rate, and that's all. I think, this is more of some more analytics we have done based on the bytes, unique pairs, average duration, top duration, unique pairs, ports, particle scan. Also, so I think that's all from my side. Yeah.
Thank you, Murugavel. Jury, please, if you have any questions for Mr. Murugavel, please ask them.
Basically, I think your solution is looking at network traffic and then doing analysis. What you have shown from towards the end.
Yeah, absolutely.
So, so it would be applicable to any network, isn't it? Not necessarily only 5G network.
See, end of the day, okay, that's a good question, sir. Actually, end of the day, a product or solution has to be adapted, right? Then only it is a product. Otherwise, it's a technology. So today we have a technology, and we are getting up to speed on the 5G domain, right? How can we? What are the vulnerabilities and so on, right? So we need to adapt to the 5G in terms of performance, in terms of customization. Say, for example, we may have to do a DPA on a particular 5G related protocol, right? We have a PDSP or whatever. If we need to still understand all those things, right? So definitely a product, I mean, sorry to say that, it has to be adapted to 5G still, yes. Today, what we have is a enterprise generic network security, which can be adapted to and customized for a 5G with the right kind of performance and so on.
Yeah, I think, but that would be applicable to any network. I think you have a generic technology, but I think if a client comes to you and then he asks you to secure the network, I think you'll have to go in through this process of adaptation because of the architecture that they will be having.
Right. So actually, for example, I mean, yeah, I agree. But for example, you know, the, the productization is completely also a commercial way of doing it, right? I mean, a commercial product features in terms of customization, right? So end of the day, we can't take the same product, whatever we have, we can't apply to 5G, which I completely agree. We need to do.
But Murugal, the question is the capability that you have, right, which
Right,
is
sir.
largely in a software defined and network function virtualization. Would it makes you easy for transition to 5G as compared to any conventional network security player?
Yeah, definitely. I think we are into SDN and NFV. Okay, we understand this 5G space, 5G space as well. We can easily transition to 5G and then secure 5G. See, that is what, and whatever that, it's not only about the firewall, but also about the, it's also about the analytics intelligence that we are building up. Okay, which can manage the 5G networks. So one about the traditional firewall or EUT next generation firewall, that is a limited. How about having go up the value chain and have a much more intelligence and effectiveness for 5G?
So where, at what stage are you in this journey? I mean, you have a technology which you have, and some of the screenshots you have shown must be from generic networks, isn't it?
No, we have done mainly for our IoT security product.
Okay. Mm-hmm.
I mean, in fact, we are not going, we are also going to planning to focus on IoT in 5G. That is also one area. We can't also, to start with, we can't go to the 5G core straight away, right? I mean, we have to start with some specific use case. How can we secure like IoT? And then we will move up the value chain.
So what stage of the journey are you in this?
No, we have a product almost ready. Okay, so we have SD-WAN as well. We are an SD-WAN also we have. Okay, and now with the more advanced security, yes, we have a product is there.
Ready for deployment?
Not ready for deployment. It's we need to do some more POCs.
Okay.
We are beyond MVP. We are product there, but we are working on POCs actually. We have done few POCs of late. We have to do much more POCs actually. Go after, yeah.
So you have showed the different interfaces, and wherever the threats could be, where the vulnerabilities could be. So you would say that the product that you have got is addressing all of those areas,
No, sir.
right?
No,
From
sir. Actually, no,
okay.
no. Yeah, okay, that's a good thing. See, what we have is a product for IoT security, right? I mean, there is a general capability we are talking about, statistical anomaly detection. There is a cloud-based orchestrator, cloud-based analytics engine, right? Which can do device classification, which can do a supervised ML, unsupervised ML, DPA-based analytics, and so on. That capability we are taking it, and now is the we are exploring how can we apply them to 5G and secure the 5G use case, 5G thing.
Okay. So how long do you think it would take for you to apply to the 5G architecture?
Yeah, I think maybe 6 months time, 6 months to 1 year max.
Okay.
Because 5G,
Am I
I
audible?
think considering Corona kind of situation, yeah, I think, yeah, because yeah.
Yes, sir, you are audible.
Yeah, so Murugavel, I just wanted to understand. You said that you have a proxy product. So let me ask a specific question because on the context of 5G adoption.
Yeah.
If you have to adopt your the proxy or firewall function as a secure edge protection proxy as in the 3GPP architecture,
Okay.
what would it take for you to do that? Is that something that is in your roadmap? That is first question. The second is that if it is, what specifically are you going to do to comply to the secure edge
Okay,
protection?
sir, that's a good question, sir. Actually, yeah, we have relevant background and thing. 5G, it's a new area. Okay, I mean, of course, it's a lot of experts are working on that, but yeah, I mean, we are focusing on enterprise security in general, and obviously, we are as a SD-WAN company, we are also supporting, looking to offer 5G as a transport, right? So that is one
Guru,
area.
sorry for interrupting you because we are running out of time. Are you
Okay,
going
so
to make a few restrictions
you can say,
or no?
we can say that we are starting our journey on 5G, and we have to adapt it. We don't have a specific roadmap. Okay, that is where we are looking support from, DSCI dot and so on. All right, I mean, because yeah, that is where we are. We are
Okay, I
ready.
got it. Sorry, I'm sorry, I'm cutting you because I know the
Absolutely,
time is running out. So the
absolutely,
second
absolutely.
question, you talked about the using the network data for doing the machine learning in securing the network.
Right.
What new additional data set that you are looking at, and what mechanism are you adopting to take the 5G specific data set?
No, sir. Okay, that's yeah, right, sir. To shock. Okay, see, we have started with only a basic. I would say basic, general supervised and supervised learning. Okay, see today as ML is a very big area, as you know, right? We have incremental learning, reinforcement learning. Now we're talking about federated learning, right? So these are the areas we are planning, and also we also have to start working more on the deep network, deep learning, right? So these are the areas I think we are going to, whether 5G is not other, we are also working on IoT security. We have a clear roadmap on those areas to work on it. So to reinforcement learning, deep learning, federated learning. So those areas we are working on.
Question
Okay.
Murigal is on data, right?
What new
Can
data
you
sets? Yeah.
Data set, I think. Okay, sorry. Data set, I think we are primarily at this point of time working on IoT 23. Primarily at this point of time, we have worked primarily on IoT data set, not the generic data sets. Like, of course, we have used some of them like stratosphere, and few other data sets. But predominantly, off late, we focus on only on IoT data set. We have say 4 or 5 data sets like University of South Wales, Bolt IoT, and so on.
Okay.
Did it answer the question?
I really didn't get any specific answer, but let's move on.
No, I mean specific data set, IoT data set only we have used. Going forward, we need to. We have to plan that one, frankly.
See the IoT data set, whether it is for 4G or 5G, would it matter, right? That if you can explain me, that will help.
No. It's not related to 5G. I mean, see, as I think I clearly mentioned that we need to kickstart our journey. I mean, on 5G.
I got the answer. Thank you.
Okay, yeah.
so the JIC, right? You use the JIC, right? And the purpose of using JIC language is what? Like,
Yeah, the Zeek is used for getting all the protocol connection related thing. Okay, you're talking about that one. Yeah, we are using Zeek, we are using NetFlow, we are using DPI, NF stream, encrypted traffic analytics. All those things we are using actually, and we are also using planning to use some signature based IDS also as well.
So from what from my response, it means 3GPP has its own security standards which are there.
Yeah.
So you are in the process of studying what 3GPP is doing, I think, before you go on start your journey. That's the.
Yeah, obviously we have to comply to the standards. Definitely, we will do a proper.
No. What I mean is that the equipment that is coming would actually be complying to those standards with the security already built in. So you are aware of that.
Yeah.
Okay, and you're in the process of studying that to see over and above that what you want to do.
Yes, absolutely. I mean, yeah, that is what exactly I was saying, right? I mean, we need to start. We need to completely complete to the standards of whatever 3GPP
Or
security.
are you looking at picking up traffic between let's say the RAN network and the core network, and then doing something on that and doing some traffic analysis?
It depends. Sir, actually, let me be upfront about it. Obviously, the best strategy is to take the low-hanging fruit, and there we can, without much of friction, we can deploy. So IoT use case is one of them. Is okay? That is kind of an overlay. Otherwise, we need to talk to institutions, and because 5G is more like a telco-ish, I would say, right? I mean, so we need to. We need to.
I think got an idea. Yeah. So you also talked about that anesthesia framework you're going to use.
Yeah.
So I mean, your complete framework are some parts of it you wanted to use. I mean, how
I mean, obviously, we have to go in a as a staggered manner. Obviously, okay. So I think we can anesthesia is for smart city level. So we need to adapt it to 5G. We need to adapt it to 5G IoT. We will go on a phase manner as well. Phase manner.
Okay. Okay.
Any other question? Okay, so we can go for the last then, Vikash.
Yeah, if there aren't any more questions, I would like to thank Mr. Murugavel for joining us today and sharing his presentation.
Yeah, thank you, Mr. Jury. Thank you so much. Thanks for listening to our ideas.
Thank you, Murugavel. And now I would like to invite Mr. Supriyo Das to the stage. Mr. Das, I see you've already raised your hand. I'll just hand you the mic.
Myself and Mr. Prabhu from April will present this. Okay.
Hello, Mr. Das, can you hear me?
Yeah, can you hear? Me?
Hello, Mr. Supriyo Das, are you there?
I'm there, but I don't know why you are not able to hear me.
We can hear you. Please go ahead, sir.
Okay. Yeah, what I'm saying that myself and Mr. Prabhu from Wipro will present this. So first of all, thank you for giving us the opportunity to present this. So
Mr. Das, just to share with you, we can only have one of the presenters on stage at a time.
Okay.
So it can either be you or Mr. Prabhu.
Okay, then Prabhu will go ahead with the presentation.
Okay, Mr. Prabhu, may I please request you to raise the hand so that I can hand you the mic and presentation rights? Yeah. Yeah, Mr. Prabhu, can you hear me? Mr. Mukesh Prabhu, am I audible to you? Hello? Mr. Mukesh Prabhu, you have the mic now, sir. Could you please respond and share your screen?
Can Mr. Supriyo do this?
Yeah, Mr. Das, could you please step in? Hello, Mr. Das, can you hear me? You can please raise your hand again so that I can hand back the microphone to you. Hello, is either Mr. Mukesh Prabhu or Mr. Das? Yeah.
So I think you are not able to hear him.
Yeah, I think it's
They're
better.
not. Yeah, Das has come back.
Mr. Das, better you continue actually.
No, main technical presentation is Mukesh, so we need him. So what he's saying that he's not able to, he's talking, but you guys are not able to hear him.
Because I think Mukesh has raised his hand now. If you can give
Yeah,
him
I'll just give him the microphone again. Let's try. Hi, Mr. Mukesh. Can you try talking now? Is anyone able to hear Mr. Mukesh Prabhu?
I can.
No,
Yeah.
I'm not able to. No.
Let me just try and invite Mr. Mukesh Prabhu to stage in the event of time as we're running out. And let's see if that works. Okay, unfortunately, we can't do that. Mr. Das, can you continue in any case? I'm not sure what the issue is with Mr. Mukesh Prabhu's system. Because I can see he is unmute and he has the microphone, but we're not able to hear him. Hi, Mr. Mukesh Prabhu. Is it working this time, sir?
No, I don't think that is working. Either Mr. Das has to present or.
Yeah. Hello, Mr. Prabhu. Can you try if there are any headphones connected and maybe that's why it's not working.
Or maybe we could reschedule it for this tomorrow.
Yeah, I think then.
Yeah, we can reschedule it first slot tomorrow morning.
Yeah. Yeah. So let's do that. Let's do that tomorrow.
Okay. Okay.
We could ask them to join a bit early so that those things that is sorted out before the meeting.
Yeah. We'll also try and move the meeting to a different platform for tomorrow. And with that, I would really like to thank all of the participants who were here today, and of course our eminent jury who took their time and helped us do the prototype evaluation. And we would be surely meeting tomorrow and furthering the discussion.
So let's start tomorrow at 10 o'clock so that we will cover this as well, right?
Okay, sure, sir.
So requesting all of you, Mr. Mondal, Professor Kiran, Mr. Rajesh, Rajiv, and Nath sir to join, and Somnath sir to join tomorrow, and Pushpendra sir to join tomorrow at 10 o'clock.
Yeah.
So we'll start with this particular Wipro's presentation and cover others as well. And we'll do it on a Teams platform, Microsoft Teams platform.
Okay.
Okay.
Thank you.
Sir.
That would be helpful. Today I had a lot of trouble, so different platform will help.
Yeah.
Thank you. Thank you, sir. The link will be shared with you in a while. And may I also request Mr. Supriya Das to, we'll also share the link with you to please join tomorrow at 10. Okay. Thank you. Thank you so much, everyone.
Okay,
Thank
bye.
you. Bye.
Yeah, everyone.
Bye.
Thank you. Bye.